always start with the concept, then we do the design analysis, and then the execution details. This is the basic format of any project when you handle. Then comes the most important part is what are the materials that you're going to execute with one, and most important, the selection of materials, how to exploit the materials for the built environment. That is the third and the very important thing. When you select the materials, what are the tools that you're going to use to build your designs? After selection, the methods and why actually you have done all this. So all this is very important when you're looking at the field of architecture. So this is our setup, which I just wanted to show you, just to understand the different kind of tools which we tend to use. The robotic arm you can see, then we have scanning, we have got water jets, CNC machines, metal laser machines, 3D printing, thermoforming. There are many, and we have got more than 100 machines today in our setup where, we use these tools to execute whatever we design. So coming to the kind of projects that we are working on, we're going to talk about one sculpture which we have done. In fact, there's an interior project that we have done for an IT park. So we're going to talk about this sculpture and, the methods of the tools that we have used along with the materials. So this is a 120-meter long sculpture that we have designed. So it is on the basis of network. So it is for an IT park. It's a lounge. It's a huge lounge of almost 20,000 square feet of a lounge, which was supposed to be designed. So we have done a small art installation on top, which is almost 120 meters, spreading over 16 meters of size, with a height of almost 3 meters. This whole sculpture was weighing almost about 100 tons, which was supposed to be suspended from a ceiling. So we were supposed to understand and select the material, which was very important for us, one. Second, with the design that we have done, how we are supposed to execute it. So these were some important aspects which came to us when we were trying to design this product. So what we did is we first 3D modeled the whole sculpture, which runs onto this whole avenue of the lounge that we have to design. So this is a metal sculpture in the first place. So the complete 3D model plan was designed. Then what we did is we tried to understand this whole model, whether it fits into the space that we have designed. And over and above, how when you're going to move below this sculpture, how is it actually going to, and how a person is going to actually feel about it. So these are the 3D renders you can see out here. So on the left, you can see how the details actually run through with respect to the human scale. On the right side, you can see again the same detail. This is a 3D projected model at the initial stage, just to understand the scaling factor. Then we tried to 3D print the whole model. So this is how you understand the whole design. We 3D printed the whole structural model into the space. We kept the human figures below that and try to understand whether the structure is feasible or not, because this is something which was for the first time we were trying to explore using different techniques. So using 3D printing to understand the actual model first, and then just to understand the proportions. Then we tried to understand what kind of material we are supposed to use to build it. So the material that we used out here was metal, cladded over with MDF with a concrete coating on top of that. Then using a metal foil to give that feel, the metallic feel. So this was the structural analysis that we ran through just to understand, what are the points that we need to suspend the structure from. So we had this whole 120-meter sculpture was suspended with almost 165 to 200 cables, which was the 6 mm thick. So we had to really understand whether this, this whole structure is really feasible or not. But fortunately, depending upon the calculated analysis that was done by our structural engineers, we tried to really fit in the sculpture, and we try to build the sculpture in such a way that it becomes very easy for any layman, for our workers or the artisans. It becomes very easy to install this product. So you can see the structural analysis diagram on the left side. On the right side, how we have unrolled the whole product. The methodology to unroll. So these are the digital tools that you tend to use to unroll, and then these are sent for G-coding, and then the whole methodology of executing the stuff happens. So this whole structure was designed in such a way that it could be the metal frames that we tend to use. They were all cut on metal laser machines, and then they were welded together just to understand the details. So what we try to do is we also 3D printed first, and then we also made a paper model just to understand the structural details, the joinery details, whether it is feasible for our welders to do it or not. So these are all the welding methods that that are shown out here in the photographs. So all metal laser cut. Every piece is being numbered. Every detail is been understood, and then it is clamped so that every piece joins together. So there were different tools like we also used cranes to execute this, just to understand whether these details could be, because this is a fabrication. So what we have done is we have not taken the structures early to the site. We made these structures at our factory, and then we have shifted them. So when you ship them, when you clad them with MDF, they become heavy. They were suspended, and then they were jacked up with the pulleys, chain pulleys, and all. So it was a very complicated issue for us to really execute this stuff. But end of the day, the product got executed, which was very important for us. Whatever we tried to do, it happened only because we had the complete backup in terms of the tools which were necessary. If we had to, if we didn't have this in-house machinery with us, I don't think it would have been possible for us to execute this stuff. So you can see how things have started shaping up slowly. The metal tubes of different sizes, they were welded on our factory, and then they were joined on site, then they were lifted. So this is how the whole concept got slowly executed. On the left side, you can see the 50% completed stuff. On the right side, you can see the metal foil which has been pushed onto it. So all this happened with completely digital parameters. So that's how it looks at the final state. So this is a completely sculpture which has been suspended from top of the ceiling. You can see a bare naked ceiling on top, and you won't even find those cables which we are talking about from where this whole structure is being suspended. So they are so thin. If you tend to see somewhere out here, you can see one of the cables. So or probably here. So these cables, these SS cables, are being the HET company has designed these cables for us with a certain structural stress analysis test that they have done, and then they have proposed these cables for us, so that with very few minimum of these cables, this whole sculpture could be suspended from the top. So this is one method where we could achieve using tools such as laser machines, metal laser machines, then metal laser welding machines, then where we had to use MDF, which was again precisely cut by CNC machines. So these are the important tools which are needed for an architect today when he's practicing this kind of an architecture. He really needs, whoever it is, the company, whichever firm it is, they really need these kind of digital tools to execute the dreams that probably we think about. You can see with different angles how the whole sculpture was suspended. Here you can clearly see those those cables on top. These are two different angles. You can see a complete video. Okay, so this is again the same project where we have to design the lift lobby as well. So we are talking about how the machines are used to build our designs. We are only talking about that. We're not talking about what project or the concept. We're not talking about that at all. It's all about using these digital tools and getting your designs executed. Same way, again, what we have used is we have used the non-metal and the metal laser machine out here. Non-metal we have used to cut our MDF again, which is cladded on top of the SS, I mean the MS model structure. So which was again detailed in such a way that the 3D model is being done first, and then everything is unrolled, and then the execution is going to happen welding all the metal details. So when you have the digital tools in your hand, it becomes very easy for executing your precise design. So that matters a lot. You can see the MDF which is getting cladded. This is also cut on the laser tools, and then it is pasted, numbered first, and then it is pasted so that it becomes easy for the person who is executing on site. So that's how slowly the whole thing got converted. In the center, you can see it is a single piece of a light which we have designed, so that the whole space of the lift lobby gets illuminated. It is a huge lobby. It's almost a 1,500 square feet lobby, which is being illuminated with a central piece of light. So earlier you have seen that the center piece has been designed in such a way that it opens up. So basically, it was the purpose for the light which we wanted. So that's how the lobby looks like when you complete your product. So what we're going to talk about things in our design is it's all about machines. When we have these machines, it becomes very easy for us for whatever designs that we are trying to do in 3D digital formats. We make sure that it gets executed. So this is how the final product looks like. So now we'll go to a different material after this. So this is about bricks. So it is again the same project that we're going to talk about, but here we have done the facade of the building. So the facade of the building was decided in such a way that we wanted to use local bricks. So these are high density bricks, which were again expensive for us to use or clad on the facade, which was not very easy at all because we had almost 5 lakh plus bricks which were supposed to be detailed out. For this, we had to cut these bricks, because of which we had to design a machine which could cut 25 bricks in 1 minute. So each and every brick we had to lay 25 bricks in a single line, and then all within 1 minute we used to get a slice of 12 mm brick. So these high density bricks were brought onto the site so that we could reduce the cost of the structure, which was very important because each brick was costing a bomb to us because it's a high density brick. So we thought of getting the brick in place and then slicing it out so that the cost reduces. And to use those things with a different pattern, that mattered to us a lot. So you can see how the machine was built first, so that we can cut these bricks, slice it out in such a way that in a short period of time we could execute almost 5 lakh plus bricks, and accordingly they were actually laid on to the final product. You can see the 3D render first, and then the bare naked the project, the facade of the building, and then how it was executed. So these were the explored details. They were, we had to cut bricks with different sizes. This could only happen because we made sure that we could have built that machine on site so that you don't have to dispatch those tiled bricks from one place to the other. So we built this whole machine on site so that we could execute this stuff. So there were almost 8 to 9 different sections which were cut, and they were detailed out in such a way that they could be placed completely as per the design that we had thought about. So that was the facade. You can see a sectional detail on the right side. So how it was laid, we had a beam, a slab, and then a small wall, 4 feet wall, on which this thing was fixed. Then the rest was the jali. This is the parking bay basically. So we wanted a jali where we wanted a complete cross ventilation to the whole space. So that's a small example that we had to create just for us to understand. So this is how the whole facade was detailed out, so that each and every piece looks like an art installation by itself. There you can see that's the top level of the parking bay, where we had this ramp which was going. So where we had almost more than 12 feet height of a jali which we had to present. So that's the corner of the building. There's the internal details of the parking bay. That's the ramp. You can see how light also plays a major important role in design. So this is the internal spaces. That the final output of the internal spaces was this. So you can see how these small 4 inch by 4 inch block which was cut, and then you have a 12 mm layer out here. They are placed on top, one above the other. This could happen only because we had these machines in place. Otherwise, it would have been a very difficult task for our labor to cut with the local machines that are available in the market today. So that's how the facade is all about. We have a small video of this. That's the transition of the shadows that you can see on the building during the day. You can see the finishing of each and every brick on the facade. So to achieve this kind of details, we really need to play around with technology all the time. We need to understand what the technology is all about. Then only it becomes easier for you or anyone to construct the whole building. Yeah. So talking about the brick, we also use different materials just for you to understand. We have to cut chira, so we have to build a machine. So we were using laterite. Chira is a local stone in the Konkan belt. So we are doing this bungalow in Vengurla, which is very close to Goa, in the Konkan, it's in Sindhudurg. So there we tend to cut chira, different kind of materials can be cut to precise size, and so that you can incorporate into your designs that you are actually trying to develop. So whether it is brick, whether it is concrete, whether it is stone, any damn material can be cut to your precise details if you really know how to use those tools. So this is a different way that we have tried to use brick and probably stone, and even you can see a slim chajjas were designed. These are those shades. It's a 1.5 thick metal sheet which was cut in such a way that you could retain it out, and it's cantilevered, and you can have a shade as well. So this is how the bricks could be cut. These are just examples that you can actually do with your machines. This is one of the buildings again in Satara. So technology is really important today for us as an architect, to use them if you are really interested in executing different projects. You can see out here again, we cut almost 20,000 pieces of super X blocks of different sizes to achieve a certain kind of a detail. So it's a hell lot of a program that you have to pass through. Each and every brick is numbered. You can see the way the things are numbered. You have a tag, there's a number. When they go to the site, the artisan who is working on site really knows, he has to just follow the drawing and follow the brick that is being provided to him, and then he can just paste it around. So these are different methods that can be, taken care of while designing. So tools really matter a lot. You can see out here as well, we cut, a lot of separate blocks to precise size. Separate blocks are available in 8 inches, 200 mm by 600 mm by probably 150, 100, 2 inches, or probably 75 mm as well. So every piece you can mold as per your need, and then you can build your props. So now we're going to talk about how CNC and the metal laser, using these things, how we have built different products now. So here what we have done is it's a mix of metal and wood which we use, and to construct a staircase in one of the residences that we are designing in Mumbai. So we cut this metal frame. You can see out here this is a metal frame that we have cut here. So which was L-shaped thing with a small bracket on top, which was fixed onto the wall, and then every step is connected to each other, and you get this kind of a detail. So the external design is CNC first. So we cut different kind of layers. If you can see the wood out here, we slice the wood in such a way that you don't waste too much of wood when you're executing it. Then you put this thing into the machine so that the machine carves out you and it gives you this form. So what happens is you are also playing around with materials where you're trying to save the material. You're not trying to use a big log of a material, you're trying to excavate things from that. So what we try to do is we first layer it out in such a way that we use less amount of materials so that you don't waste too much of material. We stack them up using different methods again, and then they are put into the machine so that you get this kind of an output. So this matters a lot. So you need to really understand how a product has actually got to be phased out to get to the final product. So this matters. I mean, the methodology that I'm trying to show out here is first using the metal brackets, which is A. The B is cladding out with wood onto the metal. C, you can see the vertical things coming up, and D, you can see the complete detail which is getting executed. So that's the methodology to execute your product. So you have different kind of tools at every place to get this output. So you don't lose on your material also. If one has to do this, probably we might think that this might be carved from one solid log. Of course, it's not. So it's from small pieces of wood that we try to achieve this thing so that you don't really lose a huge amount of wood, and the cost also reduces at the end of the day. So there's one more column which we try to do in NDF, which takes a complete load of a mezzanine. So you have this 14 feet column, and then there is this wooden member which runs into the column, and the whole mezzanine is supported on that. So we also need to understand the nature of the material, whether it can take the load or not, whether it is really feasible for us to build such kind of stuff or not. So this was done in 2014, and it's almost now 7 to 8 years where the structure is still stable, and nothing has happened to it. These are different methods to execute your stuff. When you're talking about wood, how you can do it. You can see a CNC machine pulling it out, giving a different kind of a design detail. So these things are all done first at early stage. What you do is you tend to design your models in 3D software, probably Rhino, using Grasshopper, using 3D Max, or using Maya, or using SketchUp, whatever the 3D models that you can build. Then they are taken into different kind of softwares where some kind of a coding is done. If it is for 3D printing, the technology is different. If it is for CNC, the technology is different. If it is for water jet, the technology is different again. If it is for robotics, the technology is different. If it is for thermoforming, the technology is different. So there are multiple layers of tools that are available today for us to execute our stuff. We need to, and the challenge is we need to understand which tool is important for us to execute the design in a much quicker way and with less amount of materials, and the cost becomes reduced. So these are the factors that we need to understand. So there's a lot of process that we need to go through to get to the final detail. So these are the outputs that I'm trying to show right now. This is one of the ceilings, different methodology, again using the same thing with making a raffle before, and then cladding your flexi-plan on top of it and getting out. This is almost a 40 feet length ceiling that we are doing. So now we're going to talk about how a metal laser welding is used on an SS, metal structure. So this is an installation that we did for Decode just before COVID. So this was at Worli. So here we wanted to expand steel in such a way that it covers a 3,000 square feet of an area. So the methods were different. We had to, it's small points at which the whole structure is balanced on. So we were supposed to suspend this again from the top of the ceiling using these girders. You can see the sectional detail. So that's the output of the whole fabric of steel that we are talking about. We use TIG welding in this case. So TIG welding is something else we need to understand. It's just a dot that we put on, and there are two the metal sheets that welded. I'll show you a video how we did that. So here what we did is we made a sheet first of almost 2,000 square feet of a sheet, which was then again pushed or stretched to such a thing that it could spread over 3,000 square feet of an area. So you can see how these metal points again, the methodology is again obstetrics. We had an architect called Shiva. We also have an academy where he was part of that. So he designed this just for how a metal sheet could be expanded. The whole idea was that. So this is again a small video. So that's called TIG welding. So you're using different methods out here to weld two different sheets. So it's that easy. The only thing is, as architects, many of times we are not aware of all this kind of a technology which is available in the market for us. Probably our institutes are not really helping us out in terms of understanding this technology. So, but this is what is available today for us, where you can really do a lot of research on different materials using different techniques and using different machines. So again, we suspended this with just 1.5 mm SS cables out here. That's how it was. So now we'll talk about use of 3D printing and how a stone casting can also be done. So this is one of the sculptures that we did. So this is, we completely 3D printed the whole sculpture first. The 3D model was done first. It's a huge structure again. So it was 3D printed, the whole prints, and it's like a mold, you can say. We have used 3D print as a mold out here. And then we have casted this using structural members inside the structure itself. So this is, again, a unique technique to build different stuff. So that's the 3D printed thing you can see, and all the 3D printed materials were welded together so that we can do casting. Casting was done in different layers. This is all about using terrazzo with resins and creating the structure. So you can see how the 3D molds were placed together and they were joined, and there are these structural members you can see inside, so that we can get the load onto the structure in a big way. And then the terrazzo was poured. These are different methods. Then you have to use heat guns to remove the 3D printed material, because this 3D printed material, once it is in the casting is done, it gets stuck to the resin based terrazzo inside. So you have to remove it with these heat guns. So that's how the whole structure got into. That's the end product you can see. So such kind of difficult structures can also be built if you have the right technology to use it. So using 3D printing as one of the tools for us to create this mold, using digital methods to make the design first, using these 3D printed models in the second stage, inserting the reinforcement inside the structure and then pouring this terrazzo. Terrazzo is not an easy thing, today to actually create such kind of sculpture. This is a huge sculpture. It's not a small sculpture at all. So creating this, it was a big task. On the similar method, we also designed, we got the opportunity to design Architect Krishna Murthy's sculpture. So he had actually designed this sculpture, which he termed as Jalsa. So again, the methodology was the same. We 3D printed the whole sculpture first. Then we did some structural members inside, which were actually the skeleton of the fish, which we tried to, we made the fish in such a way that it becomes, it becomes live as such. So the skeletal form is inside the sculpture. So the resin was poured inside with the stones, and you have to use vibrators so that each and every area of the mold, you set this concrete or the terrazzo concrete goes into each and every space out there. So that's the output you can see. So that's a beautiful sculpture that at the end of the day, we could finish it off using different materials. So this is all about again using CNC and hardboard with marble powder. This is a different. This is a sculpture that we did for. This is a bench again we did for Airport Bangalore. So this is kept in the TFS lounge in the international terminal at Bangalore. So this is again a small sculptural piece, but people can also use it. But still, what we did is this is again a very lightweight sculpture where we used a different kind of a technique. Earlier, what you had seen was it's a solid. Both the sculptures were solid, where we filled in the things and using the terrazzo finish. But here, what we have done is we have made this structure with ply. They were stacked, engraved. The methodology is different. Here, what we use is to cut ply. We have used water jet. So it's not CNC again. We have used different layers. Then the engraving was done. The grinding was done on the sculpture. And then what we did is we sprayed stone. So there is this technology, new technology that we have researched, where we can spray stone powder. So using resins. So these are the methodologies that we will use. These are 3D models that you can see. On the left, you can see how the layers were stuck at the first place. Then the grinding was done. Then the spraying of the sculpture was done with the artwork. So the end product is this. So now inside this is wood. It's not solid at all. So it's just layers of ply to just make it lightweight. Again, it is hollow from inside, and you have this kind of a stone sculpture present. So methods of using tools, one, and also doing research on a lot of materials which matters a lot. So getting the stone powder in place first, and then mixing it with resin, and you're getting this kind of an output. So it is just spray. So spraying stone and getting these kind of products lightweight is not at all easy. So a lot of research went into it just to understand the properties of the material, whether they will really help us out or support us out to get this kind of an output. It matters a lot. So similarly, this is completely solid now. It is all about wood. So what we have tried to do is we have cut birch ply using CNC machines. So they were all stacked. This is something which I think now it has become very easy for everybody. So we have seen these kind of stuff. There are many people who are working on this kind of style now. Yes, but making large large benches also matter. So understanding the flexibility, understanding the weight. We had to use glass below so that it doesn't drop down because it was a huge cantilever. So this is placed in the sime IT park. So that's the end product you can see. So this is a different. There were two benches in the IT park which we tried to design. Getting this output mattered to us a lot. Of course, the slicing is done, but the methods are different. Here we are trying to engrave. This is not like putting layers and then having a gap between the layers. It's not that. It's a complete solid birch ply based product. So this is completely done with CNC. So these tools are important again for you. So this is a solid carving. What we did is we have sprayed Korean, I mean we have sprayed solid surfaces. Now this is a different kind of a technology that again we have invented, taking a help from an IITian from Mumbai. It is a material analyst. So we try to understand. For all of us today, we use solid surfaces or Korean what we talk about. They come in a sheet format. So they a minimum is a 6 mm thick, and it goes up to 12 mm thick. So it comes in a sheet format. So and it comes at a size of probably 30 inches by I think 6 or 7 feet long. So there are joints. So everywhere there's a joint, and then you have to fill the joint, and we feel that it looks one. But end of the day, that there is 1 meter, but there is 1 mm line that you get to see if you see it at a distance of 1 meter. And moreover, bending Korean or probably the solid surfaces to this extent, it cracks. It's not easy. So we had to again go back to the board, understand if we can really spray solid surfaces, whether it is possible or not. So doing a lot of research for almost 8 months, we came out with a product where we can literally spray solid surfaces, starting from 1 mm and going up to whatever thickness that you want, and endless length of a surface can be sprayed, and getting the same result as solid surfaces. So this is a new technology that we try to build in our research lab in our factory, and we could do these kind of projects with that kind of stuff. So this is again stuff that we did at Bangalore airport. This is the international lounge. So this is a complete 40 to 50 feet long bench which was sliced and stacked, so that we wanted the central piece to be different. One, second, it also turns at three different areas. So we have to follow the line. So that mattered. So we had to use, again, with the help of digital tools, we wanted to make the spacers in between. So these are all the second slide that you're trying to see are the spacers. So these are the spacers which are placed at the vertical slits, so that you get the different angle. So every spacer is different. So this we could achieve it only with the help of digital tools. And we cut this birch ply with water jet. It's not easy. I mean, people don't use water jet to cut ply. But we do that because probably many of them don't know that through water we can cut ply or MDF as well. So this we could understand only because we had the tools in place. We did a lot of research, and then we made sure that, because we wanted this tool to be rectangular. You can see individual piece there. It has got an outline which has got no corners. Those corners are just 1 mm. If you cut in CNC, you get a radius of 3 mm radius circular cut at the edge. So which we didn't want at the edges. So we cut this whole ply in water jet so that we could get those exact sharp angles, and which they could be placed as a spacer in between the vertical slices, so that it becomes much easier for us to join. So these are the tools that I'm actually talking about. It is very important that you need to learn what type of tools that you can really play around with when you're working on these kind of projects. So that's the output that you're working on the airport. So you can see those spacers in the between. So with the help of that spacer, we could really turn the whole object. So that's how it looks like. So this is again a product that we try to build for for the IT part which we are talking about. So these are lift pods that we designed. So here we have a lift gadget, the pod which gets inserted into this pod, and there you press a button and the lift comes in. The information is sent to the lift, and then it comes in. So we 3D modeled it out, and then layering was done again. So this is the execution method. We try to understand whether the whole sculpture could be the box that we are talking about. They can really stand or not with these small metal brackets. Then these pieces were joined together just to understand the flow. So now that's the output. So these pipes that we tend to bend, they carry cables. You can see the iPads inside the board that we have designed. So they send information to the lift so that the lift can come in. So this is how the whole design was presented at the end. So this is again a small art installation that we did for Municipal Corporation Navi Mumbai. So this is completely metal. So we use laser welding machines and then we used metal laser cutter. So where we could achieve this kind of a detail in a very short period of time. This whole thing, this project we executed within a period of 10 to 15 years. So that's what the 3D render was. Then we first understood making MDF model, whether the sculpture will really take the load or not. We did some structural analysis. There's a structural analysis test because this was supposed to be installed in a public space. So we really wanted to understand whether the design that we are trying to execute or probably give it to the municipal corporation really takes the load or not, because these are different kind of structures which are not easy at all to build. So that's the process of metal fabrication. They were all cutting metal laser, then they were welded. This is the large footing, one large footing which was installed on site, and then these things went onto the site where we could really build this thing. So that's a small view. You can see the methods. So now we're going to talk about one more installation that we did for Platinum Marble. So this is again something really different, which the whole technology was different. While doing this, initially we thought about using 3D print technology. We thought of 3D printing the whole stuff and then pouring concrete into it, putting these reinforcements inside. But that was a failure to us. On the left side, you can see the whole model was for 3D printer. But then we understood that this was not possible at all because we wanted to use stone on top of it. So again, stone as a material, a 20 mm stone as a material is absolutely heavy. It's not simple at all. So the methods were completely different here. We were facing a big challenge in terms of executing this stuff. Such large sculptures were built in a short span of time, but to design this and build this, it took us almost 3 months. It was not easy at all, but finally we achieved what we wanted to. So you can see we used metal frames again out here. We cut metal and then joined this. So we instead of having a reinforcement inside, we used this metal tubular structure which completely was welded as per the design. Then what we did is we have cladded the stone, the Italian marble on top of this. So each and every piece of this Italian marble was numbered and it was cut to the precise size with respect to the metal piece that we had fabricated. So that's how the whole process. So here what we have done is we have used metal cladded with stone. So these are two different materials that we are talking about. So fixing stone onto a metal was not an easy job at all. So we had to use different kind of adhesives. First we had to do a lot of research on the adhesive, which was very important for us. And cutting the metal slab, I mean the stone slab with this precise details so that the complete joinery looks like as if it is built from one stone. So that you can see the output here. So the idea was we wanted the whole product to come out of the flooring that they had designed. That they had actually the flooring details which was actually laid. We wanted the whole project to, I mean the whole object to come out of the floor. So what we did is we did this whole sculpture in such a way that you have a steel structure inside and then the stone was flooded on top of that, so that when you're moving the sculpture, because when you're moving the table, it becomes very easy for a person to shift it from one place to the other because it's a table. So there's a glass top on top of that. People are going to put hands on that, put little pressure on top of that. If you have a little stress onto the actual, if it would have been a solid stone table, and using such kind of methodology or such kind of design, the stone would have been very, very complicated and would have broken if you would have been carving such kind of designs from the solid stone. So using the technique of inserting the steel frame inside and then pasting the stone on top was the best method finally which we could achieve. So that sorry, you'll see the video here. Each and every piece was made in such a way that the joinery detail continues from one end to the other. So you don't feel as if there were small pieces of stone which are cladded on top of it. The methods were completely different. We at certain areas we had to understand really how we can join these pieces so that it looks like one piece. Practicing digital architecture is not easy at all. But yes, if you have tools with you, you at least attempt and then you can really come out with these kind of outputs. So this is again a bungalow that we are doing in Bangalore. So these are the columns that we have designed. The methods were again, these are all 30 feet high columns with almost 900 mm dia, with a central column which was 450 by 450 mm, which was running up to 10 meters high. So it's almost 30 feet height of a column which we are supposed to design. So we wanted to do it in marble, but then it was very expensive to do in marble. Then we thought of going to create molds and then do casting. But again, it was difficult because the design that we had done was it was very intricate. There were things which were going inside and coming out. It's all a fluidic design that we created, and we wanted to execute that design. It was not an easy job for us. We again had almost more than 5 to 6 lakh pieces of bricks which were cut. I mean, the separate blocks which were cut, 2 inches thick blocks which were cut to precise size. They were numbered again. They were sent from Mumbai to Bangalore. On the way, there were few blocks which were broken. Again, we had to send them back. At a certain given point of time, what we thought is rather than sending them from here, we have different size CNC machines as well. So we shipped 4 of our small CNC machine onto the site because we wanted these broken blocks which were there on site. You can really cut them on site and then execute it. So there were much easier methods for us to do things. So you can see on the right side, the center one, that's a 3D printed model. This was for one of the largest 3D printed model in India, where we printed almost 32 feet height column, which was again sliced as per the design, and it was executed. You can see on the right side model where it was engraved completely. So these are the methods in which we have to execute the stuff. So that's how the stages of the whole column went through. So that's the bungalow you can see on the right side. That's the final output. Now we are going to spray stone powder on this. Now that's again a big challenge. So these are all, we've got almost 40 columns with this fluidic pattern. We have to spray the stone and then get the same detail with again having some stone inserts inside it. So there's a huge amount of process that goes through while you really want to create this kind of stuff. This is one of the 3D printed column, first 3D printed column which we did for a GDK museum, Mumbai airport. So this we had a small exhibition space where we installed this for 4 months at the airport in Mumbai. So this was the first completely 3D printed product. The output is also a 3D printed thing. So we used ABS. You can see the whole product was done with different pieces of combined pieces of 3D printed models. So we have got almost 30 3D printers out here, where we print. This whole printing stuff happened within just 2 days. So because we had a large number of printers, we could print this also. It's a 8 feet high column. So which was distributed into 64 small pieces, slightly. So these pieces were joined together to get this kind of a detail. The right side one is the 3D printed, the 3D printed model. The left side is what the 3D printed execution is did. That's how the final output looks like. You can see the design which was made on the computer render. You can see on the right side you can see the column. On the left side we also made some stools where the people could come and sit. So that's how the left model looks like. You can just see the maze of the 3D printed models which were stitched together to get the final output. So that's how the final output was. Sorry. So this we are going to talk about a little a step ahead, using materials, using technology to a certain extent as an architect, as a designer is one part. Now we have all these till now what we have seen was they were all designs that we try to design in 3D softwares, and we use certain tools to cut them, and different materials were cut, and they were laid or probably stitched or probably fixed or cut with laser machines, CNC machines, water jet machines, the thermoform, everything was done. But here what we have done is we went a step ahead to to incorporate a new technology where electronics was incorporated into the design that we are trying to do. So this is a 40-feet clock that we did at T3 Departure Lounge, Delhi. So here again, it was a very complex structure that we tried to do. So there were almost 200 plus gears which were interlocked, and a mechanism was used with a certain, I mean, we use servo motors. They were all, coded in such a way that it takes the load off each and every gear, and then it shifts the stresses to the other gear, so that the complete clock runs on its own. So we had almost 4 motors, which to run this whole system. So this was the methodology. You can see, I mean, we were just trying to play around with the stuff. Different gears were cut of different sizes, and we were just trying to understand moving with hand on the left side. The right side one is completely on machine. You can see that. So this was a mock-up that we did first, and then this is the final output. So using electronics into the project and into the product that we are trying to design, or any subject we are talking about, that mattered to us. Entering into a different dimension was mattered to us. It was a big challenge that we took as an architect, because technology is very important today. Technology is everywhere, but how you use it matters a lot. No, probably today we can completely design kinetic facades using technology, again using the third dimension that we're talking about, which is the electronics, which can be a part. Yes, our design is the first dimension. The digital tools that we're talking about, the software that we're talking about are first dimension. Second is your machines. Third is incorporating, pushing your electronics into the designs that probably we are thinking about. You can see the 3 things: the minutes, the seconds, and the hours. So they are completely almost over 200 gears, which are they run at a different surface. They're not straight at all. They run at a different surface, at a different angle, and still interlocked to get a final output. So these are a few ongoing projects that I'm going to scroll around with. These are a few things which we are coming up with. The design is complete. The execution is going on now. So this is a bungalow that we are doing, a small bungalow in Alibag. So this is an ant hill which we have designed. This is also going to come up soon. This is a pavilion that we have proposed for the India Wood Bangalore, but unfortunately because of COVID, we are not going to do this. So this is an IT park that we have designed for Bangalore. It's also going to come up soon. These are few 3D printed designs that probably with the help of digital tools you can design and fabricate them. A smaller scale to a larger scale, you can do lampshades, multiple things. There is a gym that we are doing, a fitness center. There is a staircase again, which we are going to completely engrave on metal CNC machines which we have. So this is at the design state right now. We want to execute this very soon. I mean, these things will come out. So that's a staircase that we are talking about. This is a staircase again in the same house, a different room. Also, we do some small events at our factory where we keep inviting students of different places. Small kids also do come to our place. We have architects coming to our place. We have young students passed out, 10th standard passed out students also do come to our place just to understand how the technology is used in design. So we keep on sharing our thought processes with these kids who really want to play around with technology. So these are small events that we keep on doing at our factory. Recently, we have also floated a competition for architects and students. So probably tomorrow we're going to announce the results. This is again a small exercise which we have done in our factory, where we called up musicians, and the music and the computation was running parallelly, just to understand with the help of the music what kind of forms can be created. And also you can see how people are interacting with our machines. They're trying to understand how things can be made with these machines. Now, these are live workshops that we can do in our factory. So this is a small, we are doing a Folds Academy as well, where we are teaching people the methods of digital design, the programming language, use or using technology, and execution. So it's a 4 month program that we are trying to do at our workshop. So that's it. Thanks a lot, guys. So
Thank you, Krishna. I request you to stop sharing your screen.
yeah. Mm. Yeah.
Wow, that was a marathon. I'm honestly, I'm really stunned by looking at the range of materials that you've dealt with and the kind of explorations that you have done. Honestly, I mean, I have questions with me, but I'm really sort of awestruck by the range and the scales at which you are working. Absolutely stunning, Krishna. And one thing which I felt honestly is, of course, there are tools and machines to help you, but there is a wonderful exploration in terms of materials. Okay, and it is a thorough knowledge of the material that actually makes this thing possible. And there's a wonderful sort of ability to transform, almost when you look at that installation of the stainless steel fabric, you almost feel that the material is stretched to the limit, and the strength of the steel is now sort of come and it's almost behaving like a fabric now. The same thing happens with the brick facade that you see. These are very rigid materials in that sense, but the tools and this craftsmanship is able to bring in that lightness and the geometry and everything together. So that was something also a very wonderful, wonderful thing to see. So one question, one thing which I was continuously sensing is, suppose if I talk about, let's say, the brick, I mean, we've all seen how people like Laurie Baker and Gaudi, and they have worked with the bricks and sort of created those geometry is with the help of craftsmen and their sense of the design. And so now the tool, the parametric, is helping you sort of achieve those qualities. Is it that now with this digital tools, it's becoming easier to sort of achieve those qualities in design?
Yeah, absolutely. I mean, in fact, the design that we have done, we feel that, this was the initial stage. Now, the kind of designs that we are going to come out with is every piece of brick will be different. There's one bungalow that we're doing. Every piece of brick that is going to be installed in the bungalow, every piece of brick will be different. So, it becomes much easier if you're using these digital tools. So you get that, inner sense where, you can really build things. So what
Hmm.
happens is having every brick different is not easy at all.
Hmm.
Right. So if we have to depend on the craftsman, so
Yeah.
there's a limitation for him also.
Yeah.
I can't give dimensions to each and every brick and tell him to carve it out the way I want to. Then
Right.
the time limit would be too much for me. So with the
Right.
help of this, we can really digitalization will really be the next level for the architects to seriously look into and probably practice out. So it's
Yeah.
not only brick, working with different materials. Yes, you can.
Hmm, hmm, hmm. Very true, very true. And you could see it with all the materials, in fact, with the concrete blocks, with the brick, with the stainless steel, all of that. So, if I may, I just try to sort of decode the processes. One is that first comes the design, of course, the iterations of that in the studio. Then it goes to the machine, which gives the basic form, whether it is, let's say, the sheet that is being cut and then welded to give the form, or whether it is the plywood that is cut with the water jet, or whether it is 3D printed. I get the form, and then there are this whole another layer of finishes that sort of come and do the final job, right? So maybe in the beginning, when the form is being conceived, there are designers involved. Then comes the machine, and then at some point, the craftsmen actually take over and sort of do the final job, whether it's putting the final coat and giving the finishing touches. So what's the sort of the execution processes that you've streamlined over a period of time at Folds to deliver all of this?
At the initial stage, it was very hard for us to, explain our labors. So at every given point of time, we had to really make a small model,
Hmm.
explain that, how it is going to look like, and probably 90% of the time, 90 to 95% of the time, we were supposed to sit with the laborers and teach them and probably get the final output. But
Hmm.
over the period of almost 12, 13 years now,
Hmm.
today our artisans have become such wonderful masters that,
Hmm.
even if I don't use my tools, the machine, I just give
Hmm.
them the 3D model, they'll execute it. So,
Wonderful.
that's how they have grown over the period of years, because our artisans also need to understand the technology. Our
Yeah.
artisans also need to understand how these materials are actually going to behave when they're going to execute.
Hmm.
And moreover, what are the adhesives that you're going to use when you're, the bonding materials that you're talking about, when
Hmm.
it is, whether it is brick with concrete, or whether it is stone with steel, or
Hmm.
whether it is fabric with something else, the bonding materials also do matter a lot. So it's
Hmm.
all the quality, experience, and the profits and the losses which we went through, last 13 years or 14 years. It
Hmm.
really built our artisans, our designers, to actually understand the language of visual design. So the methodology is something which, over a period of years, we have learned. We have burnt our
Yeah.
hand for so much that today we are in a position where we can execute any damn thing, whether it is stone that we are looking at, or whether we are talking about a glass structure that we are talking about, yeah, whether
Hmm.
we want to print a light.
Hmm.
So for that matter, so anything can be executed today, provided you have really quality of execution, team behind you. So artisans, yes, they do matter a lot. We call them artisans. Basically, they are simple labor, or probably they are carpenters. For the team that we have, the carpenters who are there, probably they are also our flooring people who do flooring as well. They are
Hmm.
also plumbers. They are also
Hmm.
electricians. They are also welders. The whole team does everything. So the
Yeah.
idea is, even if we don't have at certain given period of time, even if we don't have few laborers in place, let us say,
Hmm.
for a simple example, if you don't have a person who's laying the marble, I don't have to be dependent on them. I have my carpenter team who does this. So
Hmm.
we can just replace them. So every person knows each and every job. So they have become masters in their field today. So it becomes very easy for us to really build the designs that we are talking about. So
Yeah.
that's how it is. Yeah.
Yeah, it's wonderful. And essentially, what you're basically doing is design and build. So you have your own tools, you have developed it over a period of time, and so you're based in Mumbai. But as you said, in some of the projects, when you have to deliver it outside, are there kind of challenges that you come across when you have to sort of
Yeah.
deliver it?
Big challenges, big challenges. I mean, we have to have our own transportation as well, which is again important, because we have our own drivers who, really take care of our products in such a way that, the speed limit matters for them, the delivery matters for them, because many a times what happens is these are all fragile objects, fragile
Hmm.
materials,
Hmm.
especially C4X you're talking about, when you're
Hmm.
talking about marble and all.
Yeah.
Ply, it is okay, metal, it is okay, no
Yeah.
worries. But when you're talking about marble and C4X, they're all fragile materials. So
Hmm.
it really depends upon the kind of packing that we need to do at the back end. Our laborers also, the artisans we are talking about, they also do the packing.
Hmm.
Because they know that their product has to reach the site. And the people who are working on site, they also know that, how we have to unload the materials and, stack it in such a way that it doesn't become a mess. Because there
Hmm.
are so many number of pieces which are going from one place. If it's a 30-ton truck we are talking about, then almost 20 to 25,000 pieces of these small pieces of super blocks are getting transferred from one place to
Yeah.
the other, and they have to be, again placed in such a way that it becomes easy for the artisans to actually install the product. So it's a hell lot of
Hmm.
time and the process which goes into while doing this.
And
Yeah.
that's basically needed to make sure that the quality is sort of maintained, and the finally the form that we are trying to go for is achieved. So is do you think that the technologies, like for example, if I talk about, let's say, anything, like if I have to cast a concrete wall, I can get a vendor in almost any of the city, or let's say if I want to make a brick wall, I can get a vendor. So over a period of time, this sort of the parametric or digital tools will also be sort of available, and you will not have to sort of run after, produce it in your factory and install it somewhere else. So
Absolutely.
down the line, this whole processes will become like very commonly available.
Correct. Yeah, absolutely, absolutely. It should be, in fact. What we feel is, if you really want to build the designs that you're looking at, then you need to have this kind of a backup. As an architect, initially it was not, I mean, as an architect, I don't think these tools are really necessary for me if I have to practice in a very proper way, in a simple, corporate lifestyle. But we have to, really understand when we are trying to design these complicated details, long back in 2007 and all. We have to, we have to do some inlay works on the marble. There's a big problem. We have to send the granite from Mumbai to Delhi, Meerut. There was one water jet machine which was available in Meerut who used to cut the marble to the desired design, and then they used to send us. So that's where we try to understand, tools are really important if you want to really build the design that you're looking at. So,
Yeah.
that's how we ventured into, getting our tools, first the tools in place. So, getting water jet, then CNC, then thermoforming, then 3D printing, robotic, yeah, laser welding. So every machine, the metal laser, metal lathes, every machine that we needed today to develop and design or execute uh, in the field of architecture is what we have. And parallelly, what we have done is we have researched so much into the materials today. It's not only of having tools. See, tools many people might have, but
Yeah.
then what is the right tool to execute the design that you have talked about or you have designed about?
True.
Right tool, using the right tool matters a lot. For a simple example, the airport thing that I was showing, the birch ply thing, the stack thing,
Hmm. Hmm. Hmm.
when we quoted for the project, there were almost 1200 sheets which we needed to execute that stuff. And the quote was approved
Hmm.
for
Hmm.
1200 sheets. But when we came back, when we started designing, when we started nesting the whole project, it
Hmm.
went to only 700 sheets. So there
Okay.
were 500 sheets which we saved end of the day.
Yeah.
That matters a lot. So that is
True.
something. It's not just having the tools really matters, but end of the day, how you're going to use those tools really matters. The codes that are going to get generated to cut to your machines, that matters. The
Hmm.
materials that you're going to use, that matters a lot. So there's a
Hmm.
lot of research that is needed to really come out with app solutions to execute the stuff.
So, what kind of collaborations do you engage with? Like one is, of course, having artisans, but are there other people, like, for example, for the electronic thing that you did at the at the airport, the with the gears? So, are there some frequent collaborations that you do with
Exactly.
people?
Exactly. We have, these electronic engineers who are there with us, who are colleagues, who are ready to explore probably in the field of architecture, because for them also it's something different. It's not a
Hmm.
regular work that we are trying to do. So, they
Yeah.
are also very into in terms of, getting these kind of details. And probably what happens is, when we are doing this kind of stuff, we execute. Many a
Yeah.
times when they are practicing in their own field, it is just about doing research. For
Yeah.
them, it is just research. But here, what is happening is we are actually making and building the products. So,
Right.
for them, it becomes, they really appreciate in terms of participating or collaborating with us in building these kind of products. So, electronics, yes. And parallelly, as I said, when we are doing the research on spraying our solid surfaces,
Hmm.
it was a big challenge for us to find out who could really give us the right composition of getting all these materials together so that we can spray in a proper way.
Right.
It took us almost 8 months. First 2 months, we were doing a research in terms of understanding whom we should find out.
Hmm.
So, end of the day, we found out this material analyst who is a 40 years experienced guy from IIT Mumbai. And,
Okay.
we have to really go behind him and tell him, sir, we really want you to be on board, collaborate with us. The idea is this is what we have, and we want to do this. So,
Right.
it took almost 6 months for him to actually come out with the final product. at least 6 to 7 times it was failure. At the end of the day, after 6 months of hard work, we came out. So the research also matters, what kind of material you want to play around with using the digital tools, the materials and the research on those materials. All these things do matter. So now this guy whom I'm talking about is also coming up with different kind of materials and he's also doing a lot of research where he's talking about, if at all there is a wear and tear on the surface, there are internal molecules which will, break through when they come in contact with the air, the atmosphere, and then they will, restructure itself and then seal it off. And then you have to just buff it. So, they are trying to do a lot of research on that now. So
Yeah.
these are the new kind of materials which we will be seeing soon.
Very,
So
very true.
probably many of them don't know, but if you
Yeah.
really do research and you really want to work on these things, the nanotechnology that we're talking about, the
Yeah.
sealing the external surfaces so that you don't have this algae growing onto it, or less wear and tear. We're talking about
Yeah.
probably UV effects. You have to reduce that onto the surfaces. There are different kind of nano products which are available today. We just need to go and find out those materials. See, automobile industry and aeronautics, they are
Yeah.
using these products or these materials in a big way. There is a
Absolutely.
big loss in the architecture industry because probably in colleges, in institutes, we are just taught about designing, probably drawing with scale, something we are taught about. We are not taught about the research of the material, going out into the different industry, getting these materials into our industry. We are not taught about all this. You
Yeah.
know, unfortunate is in the architectural industry is we are architects. We design something, we dream something, but the other people build our designs. But that's not what happens if an artist has to really sketch something and probably he is the guy who's actually sketching it out and making the
Yeah.
code.
Yeah.
Similarly, if a lawyer has to fight his own case, he has to fight his own case. He knows what he is doing. Even doctor has to operate his own, patient. Then only he comes out with different. But unfortunate is that in our profession, we are designing, but our designs are being executed from someone else. So there is a big loss of information from one place to the other. So
Hmm.
end of the day, as an architect, you have to compromise at many places.
Yeah.
So if you have the technology within, if you're building your own production, then you don't have to worry about the loss of information that you're actually thinking about. Then you can build whatever you want. So that's the process probably we need to think about and probably change in the long run. And
Yeah.
yes, if these things, these kind of equipments are available everywhere in every city, especially for architects. See,
True.
in Mumbai, we have got, I think, 6 to 8 water jet machines, of which only one machine is available for architects. There's only one machine in Mumbai is available for architects, the water jet machine.
Okay.
Out of the 6 to 7 machines we are talking about, two water jet machines are with us. Why we wanted two water jet machines was because if we have to do a large project, then what do? You can't run around, looking out for who can really help me out. So,
Hmm.
you have your tools. Our tools, 80% of the time, the tools that we're using are completely for our projects. Completely for us. So it's, I mean, we really feel proud that, we have this kind of, infrastructure today so that, it becomes, we relax many a times that, that we don't have to worry if we have to really, if a certain difficult task has come, put across to us from our designers, so whether we can execute this or not, it becomes very easy. Yeah, we can do it. Don't worry. First of all, you are not supposed to ask a question that whether this can be made or not.
Hmm.
You just come out with an outline. We will try and build this. This is what our basic approach is. So yeah, true. These machines should slowly, every
Yeah.
city, every architect, one of the other architects should start, developing a lab, so it becomes easy for it. Today we have got more than 100 plus machines, 100 plus
Wonderful.
that's really a big investment for us. But then, on the other hand, whatever we earn, we put it into the machines. That's something which we do out here. So that's the reason why we have grown over a period of years, keeping these tools in hand. So that's it.
And it's seen in your work. I mean, that love of machine exploration and innovation is something that is very clearly been seen in almost all the work that you showed. I've really enjoyed your work, the presentation. So I could literally go on and on and on talking to you. I really feel really excited, but I think we have to follow certain time limit. So I think I would like to conclude here. Krishna, it was absolutely wonderful. It was one of the most memorable interviews that I've conducted here. It was absolutely, I was delighted to see your work, see your presentation, and nice interacting with you. I would like to thank you from the Archidiaries for giving us your wonderful time.
Thanks a lot.
And so I would also like to sort of conclude here and thank the people who have joined with us on social media platforms, and looking forward to see all of you in the coming interviews in this series. Thank you so much for joining with us.
Thanks so much.